In this video I'm going to be going over what is a loadable kernel module. In computing, a loadable kernel module, LKM, is an object file that contains code to extend the running kernel or so-called base kernel of an operating system. LKMs are typically used to add support for new hardware as device drivers and or file systems, or for adding system calls. When the functionality provided by an LKM is no longer required, it can be unloaded in order to free memory and other resources. What really is a loadable kernel model? A loadable kernel model is a way to add or remove code to the Linux kernel as it's running. It's pretty interesting, in my opinion. What are the advantages of loadable kernel modules? Modularity. Without loadable kernel modules, an operating system would have to include all possible anticipated functionality compiled directly into the base kernel. Much of that functionality would reside in memory without being used, wasting memory, and would require that users rebuild and reboot the base kernel every time they require new functionality. It helps you diagnose system problems. Disruption to the device driver in the kernel can stop your system from running at all, and it can be very difficult to say which part of the foundation kernel created a problem. If the driver of the same LKM device, however, the base kernel, is active again before the device driver is loaded, it's easy to track a problem when your system dies once you turn on and off the base kernel until the device driver causes the problem. We do not load the device drive until we fix the problem. Saves your memory. LKMs can save your memory because you should only download them if you really use them. All parts of the base kernel are loaded at all times in real storage, not virtual storage. Quick to maintain and repair. LKMs are very quick to maintain and repair. What may require a full restart to be done with the file system driver built into the kernel, you can do with a few quick commands with the LKM. You can try different parameters or change the code repeatedly in quick succession without waiting for the boot. LKMs do less, by the way, than the base kernel modules. Calling anywhere is just a branch in the place of memory where it resides. Sometimes you have to build something in the base kernel instead of making it LKM. Anything that exists that is needed to move the system far enough to load LKM should obviously be built into the base kernel. What are disadvantages of loadable kernel modules? Fragmentation penalty. The base kernel is always unpacked into continuous memory by its setup routines. Thus, the base kernel is never fragmented. Once a system is in a state in which the modules may be inserted, for example, once the file systems have been mounted that contain modules, it is likely any new kernel code insertion will cause the kernel to become fragmented, thereby introducing minor performance penalty by using more TLB entries, causing more TLB misses. Security vulnerabilities. While loadable kernel modules are a convenient method of modifying the running kernel, this can be abused by attackers on a compromised system to prevent detection of their processes or files, allowing them to maintain control of the system. Many rootkits make use of LKMs this way. So there you go. That's what a loadable kernel module is.